in order to log the seismic activity. One of the main components of a seismograph is a mass connected to a spring which it is free to oscillate. In the event of an earthquake, the seismograph relies on the principle of the inertia of stationary objects. Therefore, the mass remains stationary, while the frame and roll of paper move with the ground in all directions. The pen is used to write the seismic activity on the paper. This is the seismograph case. It protects the spring from What type of energy does the mass hold as soon as you drag it to the position of maximum displacement? Bingo! Since the velocity. Can a mass, which oscillates with simple harmonic motion, continue oscillating forever? Fantastic! Regardless the elasticity of the spring and the weight of the mass, the only way to have an endless simple harmonic motion would be to eliminate the energy loss from potential to kinetic and vice versa. This can happen if the spring you use is ideal and if the resistance of air to the motion is zero, as in this Assemble the seismograph. Great. I'll help you to attach the case. Inside the seismic station, the signals will be recorded to make the seismograms that provide all we need to know to determine the magnitude and epicenter of an earthquake. Isn't it amazing? The seismograph is sensitive to the aftershock. Luckily we are in a virtual environment and we were able to witness it without getting hurt or being in danger. Let's find out if this. Click on the roll of paper to transfer the seismogram to the wall display. I took the seismogram of the aftershock from the roll of paper and have projected it on the wall display. Click on the Calculate button to position rulers on the seismogram. The seismometer can be used to determine movements or shaking of the ground. As you know, these are the seismic waves generated by, for example, an earthquake. From which other sources can the device detect seismic waves? Ding ding ding. Volcanoes, explosions, trucks, even humans walking, generate surface waves that can be detected from a seismograph. You have to be extra careful when interpreting the signals recorded on your seismogram. The first disturbance on the seismogram is due to the primary waves and later come the secondary waves. The P waves arrive at the seismic station first, and as the S waves travel slower than the P waves, we can use this difference to calculate the distance between the seismic station and the epicenter of the earthquake. You can use two rulers to measure the distance. Let's have some fun. I'd like to challenge you to figure out the distance from the lab to the epicenter of the aftershock. Given the velocity of the S waves was 10 km per second and the duration of travel was 20 seconds. In this virtual lab, let's just assume the speed of the P wave to be infinitely fast. That way we don't need to take them into account. That's it. The distance covered by the seismic wave from the epicenter to the seismograph is given by the product of its velocity and the time of. Knowing the location of the seismograph, what is the location of epicenter of the aftershock? Click the View Image button to visualize the location. Precisely. Since your seismic station is sensitive to movements in all directions, the epicenter of the aftershock could be located anywhere at a distance of 200 kilometers from the lab. So far we know that somewhere within 200 kilometers an aftershock occurred. It would be interesting to find out the exact magnitude. Check out the Richter scale tab. Determine the magnitude of the earthquake on the Richter scale. line connecting the values in the left and right scales intersect the Richter scale at 4.5. So, in a place 200 kilometers from our lab, some people experience the shake of 4.5 in the Richter scale. I am sending your data to the National Earthquake Information Center and they will take it from there. They will combine the findings of your seismograph with other seismographs around the country and they will determine the epicenter.
A few hours after the great earthquake that occurred this morning, information has arrived to our channel from the National Earthquake Information Center concerning the latest aftershock. An aftershock of magnitude 4.5 in the Richter scale was detected close to Lapsterland earlier today. 3 seismographs from around the country provided information about the exact epicenter and magnitude of the aftershock.
Let me ask you one last question. Do you feel like... Thank you for your feedback.